In this video, I'm going to go over how to use the table feature on the TI84. And specifically, I'm going to show how to evaluate limits using the table, starting with f of x. To input my function, I'm going to use the y equals button on the calculator. And in order to get the function correct, you will need to put parentheses around the entire numerator and parentheses around the entire denominator. Then press second and window to get to the settings for the table. I'm going to start my x values at -5. Then to get to the table, press second graph. For this problem, I did start off at x is equal to -5 just to show you that there is an error for any values that are less than or equal to 0. And that's just because we have an ln of x in our function. And to evaluate ln of x, we can only plug in numbers that are positive. Then notice that at the value x is equal to 2, there's also an error. If you look at the denominator, we can't plug in 2 because it would cause division by 0, but we can evaluate the limit. So to see this a little bit better, I'm going to adjust our settings for the table. I'm going to change the table start value to x is equal to 1, and I'm going to change the scale to 0.1. To get to the table, press second graph. And now if we scroll through our table, we still see that there's an error at 2. As we look at x values that are less than 2, like 1.8 and 1.9, we can see that the y values are decreasing, and it looks like they're getting closer to 0.5. If you look at values that are greater than 2, like 2.2 and 2.1, they're increasing as you get closer to 2, and it looks like it's increasing towards the value of 0.5. And that means we have the limit as x approaches 2 of f of x is equal to 0.5. To even see this more clearly, I'm going to change some table settings. I'm going to start at 1.9, and I'm going to increase by 0.01 to get more x values. So there's still an error with the domain at 2, and if we continue to look at values that are less than 2 and greater than 2, we can see that yes, they are approaching 0.5. Now let's evaluate some limits for the function g of x. I'll start by typing in the function. Again, making sure to use parentheses around the entire numerator and the entire denominator. Then press second window to adjust your table settings. For this function, I'm going to start our x values at -5, and I'm going to increase by 1. There's a domain error at the value x is equal to -3 and at x is equal to 3. And we could determine this even without using the table because we have a rational function. And if we set the denominator equal to 0, we get the solutions +3 and -3. So the domain for the function g of x is all real numbers except 3 and -3. But again, even though those values are not in the domain, we can still evaluate the limit. And so that is, what is the function approaching as the x values get closer to 3 and -3? So to see that better, let's adjust the settings. If we look at values of y as the x values get closer to 3, on the left side, values less than -3, it goes -9, -14, -29, so they're getting larger negative numbers. If we look at values greater than but getting closer to -3, we see the values increase, but they're increasing positive numbers. Since it doesn't appear that on the left and the right, the y values are getting closer to the same number, we would say that the limit does not exist at x is equal to -3. Let's look at the value 3. For x is equal to 3, it does appear that on the left and the right, the y values are approaching the same number, which is 1.5, or 3/2. If we work this problem algebraically, we can see why the limit exists at one of the zeros of the denominator and not the other. So factoring the numerator gives us x minus 3 times x plus 6. Factoring the denominator gives us x minus 3 times x plus 3. The x minus 3 factors cancel, which leaves x plus 6 and x plus 3. So even though the cancellation occurs, the domain is still restricted to all numbers except for 3 and -3. But because the x minus 3 factor cancels, that means the 0 in the denominator, x is equal to 3, is actually a hole in the graph. For holes in the graph, it's just this single point that's removed, which is why the limit exists at this point, even though it's not included in the domain. Since the x plus 3 factor in the denominator did not cancel, it's still a zero of the domain, so it's not included in the graph. But instead of being a hole at that point, it's an asymptote. When you have a vertical asymptote for a rational function, the graph goes up or down on either side of the graph, but it doesn't connect. And this creates a situation where the limit doesn't exist.